Hi children, good morning. Good morning all of you. I hope that you all are fine. Right children, so here recording 10th class. Already we have finished some concepts. So we are starting one of the concepts, that is periodic classification of the elements. In this periodic classification of the elements, in the last session we have discussed about what is meant by periodicity. What is meant by periodicity and what are the periodic properties we have. Suppose if you want to discuss about periodic properties, means mainly we have to, depending upon, there are two factors. Those two are, one is what that is screening effect or shielding effect, and the second one is nuclear charge. Right children, see here screening effect or shielding effect means, suppose if we can consider that any atom is, in that atom consists of electrons, protons, neutrons along with the nucleus, right children. See here, when we are taking the nucleus having protons and neutrons, there is no charge for neutron, we have charge for proton is considered as a positive. That means the charge of nucleus we have to consider as a positive charge, right children. And what we have, valency electrons, only valency electrons can be participated in bond formation, right children. So that's why here maximum valency electrons are trying to come closer to the nucleus, right children. That's what we have to thinking here. Here in between nucleus to valency electrons we have force of attractions. What we have children? Force of attractions, right children. So between valency cell and nucleus, what we have? Some inner cells we have, some inner cells. Those inner cells also having some inner electrons, right children. See here, suppose if the valency electrons are comes closer to the nucleus, means here in between valency and inner electrons are there. Those inner electrons are, it will be repulsed to each other. So based on that, here the attractive forces between nucleus to valency electrons are less. That means it will be lower compared with the repulsions between the inner electrons. That's why here inner electrons, see here inner electrons, here these we have to consider the inner electrons. These we have to consider the inner electrons. So these are the inner electrons. Suppose these valence electrons maximum comes close to the nucleus, means these inner electrons will be, it will be reduce the force of attraction between nucleus to valency electron. See here, to reduce the force of attraction, between nucleus to valency electron is called as shielding effect or screening effect. What children? Shielding effect or screening effect. Right children, already we discussed about this in the last class, right children. So this is the one of the factor to discuss about periodic properties, that is the screening effect or shielding effect. What children? To reduce the force of attractions between nucleus to valency electrons is called as screening effect or shielding effect. So this is the screening effect or shielding effect is mainly depending upon the inner electrons. If the inner electrons are increases, means screening effect also increases. If the inner electrons are decreases, means screening effect also decreases, right children. So this is the one of the factor, that is the screening effect. And the second one, what is the second one children? Nuclear charge. What children? Nuclear charge. What is meant by nuclear charge children? See here, when the valency electrons are comes close to the nucleus, means automatically the charge of the nucleus is increases. So what is the charge of the nucleus children? So what is the charge? How many protons are there in the nucleus? That is we have to consider as a charge, right children. Suppose if we can take the lithium having 3 electrons and 3 protons. That's why the charge of lithium is 3. Suppose if we can take sodium, the charge of sodium is 11. If we can take the beryllium, the charge of the beryllium is 4. Like that, based on the atomic number, we have to consider as a charge of the particular atom. But here we need to discuss about effective nuclear charge. Or children, effective nuclear charge. See children, What is meant by effective nuclear charge? See here, effective nuclear charge. Effective nuclear charge. See children, effective nuclear charge. What is meant by effective nuclear charge? Means here effective nuclear charge. Here sigma star. What children? Sigma star. Here we have to consider say sigma equals to Z minus sigma star. Z minus sigma star. Here sigma is the nuclear charge. Sigma is the effective nuclear charge, and that is the atomic number. That is the atomic number, and sigma star is the screening constant. Sigma star is the screening constant. Right, children? See here, to discuss about screening constant. We need to learn about Slater's rules. Slater's rule. Already in the last session I sent in one of the video, that is the very important video. I think that you are already understanding that Slater's rule. Once again I am repeated that. Then after I will go for periodic properties. Right, children? See here. How can you find out the screening constant values? See children, suppose if we can consider the atom. In the atom, what we have, children? Here this is the first cell, second cell, third cell, fourth cell. Right, children? Here first cell, second cell, third cell, fourth cell. Okay. See here, suppose if we can consider that. Here the last cell of an atom we have to consider the valency cell. What's your name? Valency cell. The cell just before valency cell or ultimate cell we have to consider the penultimate cell. What's your name? Penultimate cell. The cell just before penultimate cell we have to consider the anti-penultimate cell. What's your name? Anti-penultimate cell. So these are all. This is the last cell we have to consider the n. So penultimate cell we have to consider say n minus 1. Here anti-penultimate cell we have to consider say n minus 2. So then remaining these are all we have to consider say anti-penultimate cells. Anti-penultimate cells. See here, valency cell, it is having screening constant values, that is we have to consider say 0.35 children. What children? 0.235. See here, then n minus 1, that is the 0.85. 0.285. And here remaining these are all 1.0, 1.0. See here, for s and p orbitals, 0.35, 0.85, so like 1.0 and 1.0. That means, see here, I will be the one of the tabular form children. Here for s and p orbitals, n values, n minus 1 values, n minus 2 values, n minus 3 values. For d and f orbital, f orbitals. See children, about s and p orbitals, here n value, n minus 1 value, n minus 2 value, n minus 3 value. N value for S and P and D and F we have to consider the 0.35 and 0.235. For n minus 1 it is we have to consider 0.85, here it is 1.0. For n minus 2 these are all we have to consider as 1.0, 1.0, 1.0. Right children? So based on these values we have to find in the screening constant values. Right children? See here, suppose if you want to finding the what is the effective nuclear charge for lithium, what is the effective nuclear charge for sodium, what is the effective nuclear charge for potassium, we will discuss now. Right children? See here, first of all, suppose if we can take the what we have the first year group element children, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Right children? See here, suppose except hydrogen, so what are the remaining elements? Lithium, sodium, potassium, rubidium, cesium, francium. These are all first year group elements. These are all first year group elements. First, we need to find what are the effective nuclear charges for these values. Right children? See here, first of all, lithium. See here, see children, this is the table form, which is very important children. Suppose if we can take the lithium. What is the electronic configuration of the lithium children? Electronic configuration of lithium is 1s2, 2s1. So 1s2, 2s1 means here first cell consists of 2 electrons. First cell consists of 2 electrons. Second cell consists of 1 electron. So this 1 electron is valency electron. This is the nucleus. If these 2 electrons are not there, means this is electron easily comes to the nucleus. But here these 2 electrons will be acting as a screening effect between nucleus to valency electron. So how much it is screened? How much it is screened? That we have to find out the screening constant value. Here this is we have to consider as a n, last cell, and this is we have to consider as a n minus 1. That is the penultimate cell. Right children? See here, these two are screening the screening effect between nucleus to valency electron. That's why we have to find out the sigma star. We have to find out the sigma star. See here, sigma star means, how can you find out the sigma star means? See children, here what we have here? We have how many electrons are screened here children? 2 electrons. 2 into, for n minus 1 value for s orbital. N minus 1 value for s orbital is 0.85. That means 2 into 0.2, 2 into 0.285. 2 into 0.285. 2 into 0.85 means, here 2 into 0.85 means how much children? 1.7. What children? 1.7. And here, now we have to find the sigma equals to z minus sigma star. Sigma equals to z minus sigma star. That means, here z is, we have to consider the atomic number of lithium is 3 minus 1.7. Then how much we are getting children? Here the effective nuclear charge for lithium is 1.3. What is the actual charge of lithium children? 3. But effective nuclear charge of lithium is 1.3. 1.23. Let me see here. We have to find in the one more atom, that is the sodium. Suppose if you want to find it for sodium means, here sodium, electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. We have to find out the screening constant for last electron of the sodium. That remaining electrons are 10 and then electrons are there. That means, see children, this is the one of the group. Then we have to consider this is the one of the group. 1s. See here, not like 2 electrons. This is the last cell. This is the n minus 1. This is the n minus 2. See children, see here for sodium, we have to find out here sigma star equals to, how much children? Sigma star equals to number of electrons, n minus 1s2 means there are 2 electrons are there. N minus 2 values for s orbital is 1.0. That means 2 into 1. 2 into, this is the 2 electrons, n minus 2 value for s and p orbitals 1.0. So 2 into 1. For n minus 1 orbital, s orbital 0.85. Remaining 2 plus 6, so 8 electrons are there. That means 8 into 0.85. 8 into 0.285. So 2 1 are 2 plus 0.85 into 8. 0.85 into 8. 0.85 into 8 means 8 5s are 40. 8 8s are 64 plus 4, 68. That means 6.28. How much today? 6.28. So totally how much we have today? 8.8. So then we have to find out the effective nuclear charge sigma equals to z minus sigma star. Then here z value is 11 minus sigma star value is 8.8. Then how much we are getting children? 11.0, 8.28. So 2, then here 2. Then how much we are getting children? 2.2. Here effective nuclear charge for sodium is 2.2. 2.22. See children, actually the charge of the nucleus 3. Here it is 11, here it is 19, here it is 37. Like that we have nuclear charges. But effective nuclear charges are gradual. What will happen children? Decreases. Gradual it is decreases. Let me see here. For example, if you can take the potassium. So potassium means how many electrons we have children? Totally 19 electrons we have. See children, about potassium, suppose if we can consider potassium, what is the electronic configuration of potassium children here? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. See children, totally how many cells we have? There are 4 cells we have. So there are 4 cells we have means, here children, we have to find out the screening constant for potassium for the valency electron. Then here sigma star equals to, here how much children? This is the answer, n minus 1, n minus 2, n minus 3. Here sigma star, this is the n minus 3. N minus 3 for S&P orbitals means that is the 2 into 1 plus 2 plus 6 8. 8 into n minus 1, n minus 2, that means 8 into 1 plus 8 into 0.85. 8 into 0.285. Now 2 plus 8 plus 8 into 0.85 means how much we are getting children here? 6.28. 6.8. So total 8 plus 2, 10. 10 plus 6, 16.8. 16.8. But what is the atomic number of potassium children? So then sigma equals to Z minus sigma star. So Z means 19. 19 minus 16.8. So 19 minus 16.8 means how much we are getting children? 10 minus 8, 2. So 9 minus 6. Sorry, 8 minus 6, 2. Then how much we are getting children? 2.2. See children, here also we are getting 2.2. That means here, when we are comparing the effective nuclear charges from top to bottom in groups, it is decreases. See children, so here actually charge of potassium is 19, but what is the effective nuclear charge? It is 2.2. That means effective nuclear charges are gradually decreases, right children? So like this, based on Slater's rule, we have to finding the what is the effective nuclear charge of the particular element, right children? See here, you should try that some examples at your home based on by using these values, right children? So whatever it may be, what I am saying here, if it is the nucleus, here from the nucleus to valency electron, what we are saying here, if the number of inner electrons are increases means screening effect is increases. If the screening effect is increases means nuclear charges decreases. Nuclear charges decreases. See children, what is the relation between screening effect and sealing effect? Sealing effect or screening effect and force of attraction means, see children, here suppose if we can consider the atom is, this is we consider as a nucleus, this is we consider as a valence electron. If the number of inner electrons are increases means what will happen children? If there is no electrons means the force of attraction between nucleus and valence electron is very high. But when we are taking the more number of electrons present in the inner electrons means, when the number of inner electrons are increases means sealing effect is increases. That means sealing effect is here number of inner electrons are increases means sealing effect also increases. When the screening effect is increases means force of attractions are decreases. Force of attractions are decreases. That means number of inner electrons are directly proportional to the screening effect. Screening effect is inversely proportional to the force of attraction. Screening effect is inversely proportional to the force of attraction. If the force of attraction decreases means automatically effective nuclear charge is decreases. Effective nuclear charge is also decreases. Right children? That means screening effect is inversely proportional to the nuclear charge. Screening effect is inversely proportional to the 1 by nuclear charge. That means here force of attractions and nuclear charge is directly proportional to each other. Force of attractions and nuclear charge is directly proportional. Screening effect and nuclear charge inversely proportional. Screening effect and force of attractions are inversely proportional. Right children? See here, if the screening effect is increases means force of attractions are decreases, and automatically nuclear charge also decreases. Right children? So now these are the 2 points. What are the 2 points children? One is screening effect or shielding effect, and the second one is nuclear charge. So these two can play the main role to learn about periodic properties. Right children? So in periodic properties, what we have the children? We have some periodic properties we have. What are the periodic properties we have? Now that is we have to discuss now. Right children? See here in the periodic properties, the first periodic property is atomic size. What children? Atomic size. So now we are going to discuss about atomic size. Right children? So before we are going to discuss about atomic size, how it will be varied in periods and groups. That means how it will be changed in the periods and groups. We have to discuss about what are the types of atomic gravity. Right children? See, let me see here. The first periodic property, that is the atomic size. What children? Atomic size. See here, the first one is atomic or atomic radius. See children, what is meant by atomic radius or atomic size? See children, the distance between this is we have to consider as a nucleus. This is we have to consider as a valency electron. What children? Valency electron. Here in mathematically what we are saying here, suppose if you can consider the circle means this is we have to consider as a center of the radius or center of the circle, and this is the total distance we have to consider as the radius of the circle. So but here the distance between nucleus to where the valence electron is present in the atom we have to consider as a atomic radius. What do you mean? Atomic radius. Here this is the atomic radius we have to represent with the letter R. Right children? See here, this is the atomic radius we have represented as a R. Okay children? See here, what is the definition of atomic radius children here? What is the definition of atomic radius? Here, the distance between nucleus to where the valency electron present in an atom. Here the distance between nucleus to where the valence electron is present in an atom is called as atomic radius. What children? Atomic radius. What children? Atomic radius. But here, suppose if we can take this is the atomic radius, it is the one of the atomic radius, this is the one of the atomic radius, this is the one of the atomic radius. So number of radiuses we have to consider as a plural sum. So those number of atomic radiuses we have to consider as a radii. What children? Radii. So that's why we have to consider as atomic radii. That is the atomic radii we have to call as a atomic radius or atomic atomic size. What children? Atomic size. See children, atomic radius or atomic size. What children? Atomic size. Here, what are the units of atomic size? Here, atomic size, it can be expressed in terms of angstrom units. It can be expressed in terms of angstrom units and picometers and millimeters. Right children? 1 angstrom unit equals to 10 to the power of minus 8 centimeters. 10 to the power of minus 8 centimeters. When expressed in terms of meters, 10 to the power of minus millimeters. And 1 picometer equals to 10 to the power of minus 12 meters. Right children? So here these are the units of atomic size. Right children? In the next class we will discuss about what are the types of atomic radii or what are the types of atomic size. Okay children? Right? So please, each and everyone, you should write the notes clearly and you should understand the concept. Right children? Okay? Thank you.